Hello everyone. Recently I decided to relearn the Python core from Epam. It's a part of data software engineering course. Yeah, I have go through all the models here and I decided to share my experience and also explain the most of the concepts like human being. Let's get started from the lesson 1 introduction. Okay, firstly, welcome to Python core. Yep, let's get started. We will learn in this module about the Python, about development environment, its data types, functions, models and packages, and last but not least, the object-oriented programming in Python, how it looks like. Let's move on. Okay, introduction. Why you should choose Python or you should learn the Python. Actually, Python is beginner friendly, multi-purpose, high demand nowadays, and it also has a wide community. Python is one of the most fast growing programming language. It's used everywhere, from web programming to AI, artificial intelligence. In this module, we will learn about types of programming languages, introduction to Python. We will code some problems. Okay, types of programming language. What we have, there is a table. We have you can see its ranking. Python is the first according to TIOB index programming language. It's divided into 5 by purpose, by level of abstraction, programming paradigm, implement action, and typing strategy. Let's talk about the purpose. We have general purpose and special programming language. For general, we can say Python, Rust, Java, Lisp. It's used for various tasks. For special programming language, it's oriented for solving the specific task, like SQL for database or Maple for mathematical computations. And we have level of abstraction, low level languages or higher level language. For low level language, machine code or assembler. For high level language, it's Python, Java, Ruby, and JavaScript. Why? Because it sends indirect calls to the operating system using abstraction level. Low level language will send the direct calls. Difference is this: direct calls, but high level language it's indirect calls, and it uses the compiler or interpreter to translate them to operating system, to machine code. Okay, next, programming paradigm. We have declarative paradigm like HTML or SQL. Like it says, you don't need to know about how browser renders the HTML. You just describe what you want to see, you have the results. Same with SQL. For imperative paradigm, Python, Java, the main goal of imperative programming is to describe the process. Functional programming, we can say part of declarative programming, which has a chain of function calls. Like you can see in the image, program, function, result will go, move on, like this. It has some advantages and disadvantages, like recursion dips. As you can see there, it will continue and go deeper and deeper. And for advantages, I can highlight it's easier to understand. Object-oriented paradigm. Like here, you can see in the image, and class car and objects like BMW, and Mercedes inherited from the class car, because this is a car and this is a car, just the model is different. Advantages, it's parallel development. Each team member can work independently with their own model or classes, and also it's scalable and maintainable. For disadvantages, it can be inefficient. Using OP can increase CPU usage, and also unnecessary classes that can lead to duplications. Yep, let's move on. Procedural paradigm, it's also part of imperative programming. Advantages is easy to reuse, also it consumes less memory, but in the disadvantages we can see there is no data protection. It's also difficult to handle errors. And example, Pascal or other programming language. And for implementation, we have two types: compiled and interpreted. For compiled language, we can say it's C, Go programming language, because it will translate the source code from high-level programming language, lower-level language, and it leads to faster execution, because as you can see in the image, language, it's compiling to machine code and it's ready to run. But an interpreter, there will be interpreter that will transform the source code to bytecode, and then it will be executed by interpreter. As you can see in the image, disadvantage is slower execution. It takes much time compared to compiled language. Okay, we have typing strategy like dynamic, strong, static, weak. Dynamic code, we can see everything will be checked at runtime. You don't need to declare each data type in the beginning, like in the Python. There's no you don't need to declare like int, integer, and equal to something. In the strong type language will permit the mixing types like in the expression, and they don't apply different implicit cast like C#. For static, you should always declare the data type like in the C++ or Java. And there is also weak typing language that implicit cast of types. As a result, the output of some expression may be surprising, like example of C++ or C language. Okay, here you can see the difference between dynamic with static. Here, as you can see, we define the function mean and we pass the array. We don't declare the array as it's a list, or in the result we put int as a data type. Python will know itself while interpreting it, transforming source code to bytecode will itself. But in the static example of C, we can see function double mean because it will return the double, and here you can see we put double and array, and also we put the double before result. We should in the static types we should declare before in our code its data types like double, integer, string, float, or vector. And also here you can see strong and weak. In the strong we can see like we cannot add 42 to string because this is a string but this is integer. Before adding you should convert integer to string like here str parenthesis 42 plus string like here, and then here you can add. But in the weak like example of JavaScript, it will add itself because it's a weak language, in short I can say. Let's move on. Okay, introduction to Python. I hope you know the founder of Python, Guido van Rossum. He started working in the late December 1989, and first version was released early 1990. And also language was named Python because the Guido van Rossum really liked the comedy show Monty Python's Flying Circus. Okay, let's define the Python. We already know purpose, level of abstractions, and we can say that Python is general purpose, high level, imperative, interpreted, strong and dynamic typing programming language. Okay, for general purpose, why it's general purpose? Because we can use Python for scripting, for web development, for data analysis, for machine learning and AI, DevOps and system administrations, tests, automation, and prototyping. Okay, we already know why it's high level and why it's interpreted, because source code will be compiled using Python VM to bytecode. a Python compiler to bytecode, and then Python VM to machine code, and then computer. Oh yes. Yeah, it's object oriented. In Python, everything is object. Even functions are object. And dynamic. Yeah, it's dynamic. You don't need to put int before x or string before y. It will know itself during the execution. There are some advantages for Python, like easy to learn. It's easy, like you learn the English language, you will learn the Python programming language, almost same. And it's fast development, a lot of libraries, a lot of standard libraries, a lot of frameworks, Python, Django, Flask, FastAPI, a lot of. Also, it's dynamic typing. You don't need to declare data types in the source code. And also, it's portable and extensible because there are extensions. There are extensions for Python for C and Jython for Jython. I don't know how to pronounce it. For Java, .NET. Yeah. And it's free and open source. You can always go to python.org and download the version that you want to work with. Let's go ahead. Just go ahead. Okay. Yep, but there are some disadvantages like speed, because it's interpreted. For sure, speed will be less. And also, no multi-threading like in Java, or high memory consumption, because you're not declaring the data types while coding. It's dynamic. Because of this, it's consume high memory. Okay, let's move on. Interactive Python. Okay, okay, here you can see some keywords for Python. Use it. Yeah, they already researched. You can't use this as a variable in your projects. Okay, let's move on. Next. Python installation, PyCharm installation, Git installation, GitLab. Okay, I hope you know about Python, how to install Python. You just go to python.org and download the version that you want, or just download the latest version. That's it. For PyCharm, you can install the PyCharm, or you can install the PyCharm from JetBrains, or you can install the VS Code, also Visual Studio Code, as you wish. Git installation. Yep, just need to go to gitscm.com and download. Click on the download here, choose your operating system, Windows, macOS or Linux, and just download it. Okay, let's move on. GitLab. Yeah, why they are saying GitLab? Because here there is some, I can show you practical task numbers. There's some practical tasks that are pushed to GitLab, not GitHub. That's why they are pushing to have a GitLab account. But you can open GitLab as well, gitlab.com, or just GitHub by typing github.com and create an account. It's really easy. I hope you will do it yours by yourself. Let's move on. Don't need this. We don't need this. Okay. Let's learn about the data types. Data types like numbers, conditional operators, loops, stringers, lists, tuples, sets, and dictionaries. Let's move on. Data types. Okay. Data types, variables and objects. This is A, we assign to 1, and it says their integer data type is just, this is integer, this is a string. In Python, everything is object, and object is an instance of some class. Everything is an object. Even classes are functions. Okay. Python standard data types. We have numeric data types like integer, float, or complex numbers. And strings. Everything that is written inside double quotes or also one quotes is string. And lists. Lists, we can say also like array, and for this list is a sequence of elements inside square brackets like here. You can put everything here. It can be integer, it can be float, it can be Boolean, or it can be also string. Tuples. It's also like, it looks like same to lists, but it's enclosed to parentheses. As you can see here. And sets as an unordered collection, and it doesn't allow any kind of duplicates. Dictionary. It's a mapping of k-value pairs with k-value pairs, like message, hi, or birthday, some year, name, some name, like k and value, like mapping. Okay, we also have mutable and immutable objects. Like for mutable, it's objects that can change after their creation. But in immutable, you cannot change the type of after its creation, like integer, float, string, or tuple. Let's move on. We have operators and operands. Okay, first, what are the operators and operands? It says, like in simple terms, in the expression 2 plus 3, the numbers 2 and 3 are operands, and cyan is operator. We have unary operators, plus and minus, binary operators, less or more, and equal or unequal, and ternary operators like else, if. For arithmetic operators, we can group like plus, minus, multiplication, division, and etc. And there is also assignment operators like plus and equal sign, minus or equal sign. It will assign the right value to the left value. Let me show you the example. Okay, let's assume we have a 0, a plus equals to 1. If we print a, it will print the 1 here. This is same as a equals to a plus 1. Yep. With minus is the same scenario, but here will be minus and minus. We have also we can put also the multiplication or division. Same here, division or multiplication. Okay, we have comparison operators like equal sign, not equal sign, greater or less. Logical operators and, or not. And membership operators like in, not in, and bitwise and bitwise or bitwise XOR. For comparison, we can say 1 equals to 2, and we can print this. It will say false. We can put inequality. It will say true. Okay, AND operator. One and one. Print. It's true, like if we put 1 and 0, it will say false. Let's move on. Okay, let's talk about the numbers in Python. There are 3 different types of numbers in Python: integer, float, or complex. This is an integer, like we assign a and we assign it to variable a 100. We assign also minus or such a huge number. And if we have a like integer that in double quotes, like string format, we can always convert to integer, like just int, parentheses, and x. It will convert to integer, and we can see the type y, and here integer. It's converted to integer. Let's move on. We have float, like floating point numbers, like we have variable a and we assign 7893.45. We can also use scientific notation like 1.0, e, and 0. And here we can always convert string to float to integer, integer to float, from one data type to another data type. We have also complex numbers. Yep. Let's move on. Okay, there is a simple calculations. Let's not waste time for this. We don't need this. Let's continue. Let's move on. Boolean comparison. Boolean operators allow for defining the logical expression or can be used by control flow statements, but comparison operators provide different options for comparing the values with each other. Like we can here compare like result equals to 3 greater than or equal to 1 and 10 less than 20, and this is true. Why? If this is true and this is true, result will be true. If one of them is false, the result will be false when we use AND operator. But if we use OR operator, if this is false and this is true, the result will be true also. Because in OR operator, one of them should be true and it's enough. And NOT operator, it will just we can say make true to false and false to true, like opposite. We can see here string, and we are checking A equals to B. The result is true. Okay, let's move on. Okay, we have also conditions with flow control statements like A equals to 20, B equals to 33, and minimum is 3. And we here checking if A less or equal to minimum and B more or equal to minimum, result will be A plus B multiplication to 2. Else, if this statement is incorrect, this part of code will not be executed. It will go here, else, and the result will be 0. But in our case, A is 20 and it is more or equal to minimum 3, and B 33 is more than or equal to 3. In this case, result will be A plus B, it's 53 multiplication by 2, and it's 106. We have also abeeelive or else if statement where we can use abeeelive. Actually, we can also if we use here if, it will check this and this also and then prints out. But an abeeelive, it will check this. If this is true, it will just print out. If this is incorrect, it will check this and print out. But let's imagine this is not abeeelive, but this is if. It will check this. This is true, but it will also check this because we use it if here, and then prints out. This is a main difference between if and abeeelive. Let's move on. Nothing.